So next, let's move on to example 4 here. So we've got that WXZ is congruent to DFG. It says use the diagram to find the following. They want us to find the scale factor. Okay. So when you're doing scale factor, you need to know which one's your image and which one's your pre-image. And usually it should be a little bit more distinct. It should, how about this, of this to that. So we'll say this was our start and this was our end. Okay. Now, when you're talking about scale factor, you can use different terms. The proper term would be pre-image and image. A lot of times I feel like it's easier to just refer to them as the old and the new. Whatever works, works. And if we look back up here, how do we calculate scale factor? I said image over pre-image, new over old. So what you have to do here is you have to find two corresponding sides and find their ratio. So bear with me here. I'm looking and I've got information on WX and DF. And those look like they might be corresponding, but let's just make sure. WX is the first two letters and DF is the first two letters. So that tells me that they are corresponding sides, so I can use them to find a ratio. Now, DF comes from my DFG, which is my image or my new. So that guy's going to go on top. And then my WX is going to go on the bottom because that is my pre-image or my old. So it's going to be 6 over 4. So really your scale factor is going to end up being 3/2. All right. So now let's go ahead. They ask us for the measure of angle Z. You guys should be able to calculate this out. What is the measure of angle Z here? So to get the measure of angle Z, you would just do 180 minus 37 minus 90, which is going to give you 53. All right. Next, they want us to set up a proportion here. So we have DG on top and WZ on the bottom. You can see that these are corresponding. We can double check that they're corresponding. DG is the first and the last, and WZ is the first and the last, sorry. And then they're going to give us WX, which is this guy here. And we know that WX is the first two letters. So then what two letters do we need from our other figure? If we took the first two letters from WXZ, what two letters do we need from DFG? We're going to need D and F because those are the first two letters on there, which makes sense. Those are the corresponding sides. All right, next, they want us to find the measure of GF. Now, this is going to be a little bit more tricky, so bear with me here. We need to set up a proportion. So they want us to find this guy here. We don't know what that is, so we'll put an X. And we know that FG's corresponding side is going to be XZ, because they're the two last letters, which is great because we have that value. So we'll do our image over our pre-image. All right, so we're going to do X over 3 equals, and then we have to pick 2 more sides to use the ratio of, and it has to be a pair of corresponding sides. So let's look. We could use DF and WX. If we look, those guys, DF and WX are corresponding. It's both the first and second letters. So we can use those. And again, we did image over pre-image, so we're going to do 6 over 4. Now let's go ahead and cross multiply. So we would do 4x equals 18. Divide that by 4, and I would get 9 over 2. Or you could say 4.5. Those would be 2 valid answers. So next, let's go ahead and try and find angle G. So angle G is going to be, is this guy here. So you need to figure out which angle, or actually they're asking for the measure of angle G. All right, we did say that Z was 53, right? And we know that G and Z are corresponding angles, so that means that G has to be 53. Now I want you to go ahead and find the measure of angle D. Figure out what angle from the pre-image corresponds with angle D and what the value of that is. So D corresponds with W. W is 37, so D has to be 37. All right, lastly, we got to set up another proportion here. So they gave us WZ, which is this guy, and ZX, which is this guy. All right, now before we haven't set them up this way. Now remember how we talked about how you can kind of like rearrange proportions? Basically, the way we're gonna do this now, instead of doing like one from here over one from here, we can put them on different sides of the equation. So let's show it this way, I guess. We have WZ and we have DG. You see how these are corresponding? So you can set them up this way as well. Instead of putting them on top of each other, you can set them equal to each other. And then we've got ZX, right? And you can see, well, what part goes with ZX? It's going to be GF, right? Let's go ahead and turn to the 6.3 day 1 homework, and we'll go over a couple of these problems, or at least one of them. So they tell us that polygon HJKL is similar to polygon WXYZ. So they want us to find the scale factor from this to this. All right, so that means that this is the old, this is the new, or we could say that this was the pre-image, and this is the image. So remember, it's always new over old, or image over pre-image. All right, so we need to pick a side that clearly goes together. All right, so I would say these look like these would be good sides to use, but let's double check that they are corresponding sides by looking at the similarity statement. So we have HL, which is the first and the last, and we have WZ, which is the first and the last. So that shows that they do correspond. It's always good to double check that they are corresponding. So next we're gonna go ahead, we need to do our image over our pre-image. So our image here, so this is our new, this is our old, we're gonna do 2.5 over 4. All right, and again, I was able to use these because these are corresponding sides of similar figures. So I'm going to do 2.5 divided by 4, and that gives me a scale factor of 0.625. All right, perfect. So this is our scale factor. Let me erase all this craziness. Now let's go ahead. They want us to find WX. All right, so WX, let's do it in a different color here. WX is the first two. So if we look, we're looking for this side here. So we need to look at our other figure that we need to use the first two letters on there, which would be HJ. Perfect. So let's go ahead. Let's set up our ratio. So in order to set up a ratio / a proportion, where you need to make sure that we are using corresponding sides and keeping it consistent. So let's stick with the new over old equals new over old. Okay. All right, so we have our new, which is 2.5 and 4. Why did I pick these? Well, we need to make sure that we have at least one set of one pairing so that we can solve for the unknown, so that we're able to cross multiply and divide. So then now we can go ahead. We're going to do, again, new, which that's what we're trying to find. That's our unknown there, over our old, which is 16. All right. So let's go ahead. We can cross multiply. So we're going to do 2.5 times 16. And we get 40. And then we get 4x. And we end up, oops, with x equals 10. So Wx has to be 10. All right, now they want us to find the perimeter of WXYZ. All right, so let's take a look here. The perimeter is when you add up all of the sides. So we're pretty close. However, we're missing this side here. But it has this little tick mark, and we know that this side is 10, so that means that this side needs to be 10. So now to find the perimeter, all we have to do is add all of these up. So we would do 2.5 plus 5 plus 10 plus 10. And when I do that, I get 27.5. Then they want us to find JK. All right, so I'm going to erase these a little bit. Let's use a new color. They're looking for us to find JK. So we need to look at the middle letters, which means we are interested in XY. All right, so we have JK and XY. So again, we need to set up a proportion. So we know we are looking for JK, so we can even just put an X there, and we'll do new over old. So we're going to do 5 over X, and we need to pick a side to use as buddies. So how about let's stick with the purple side, and again we have to do new over old. So we're going to do 2.5 over 4. We'll cross multiply. We get 20 equals 2.5x. Divide by 2.5. 20 divided by 2.5 gives us 8. So that means that this guy is 8. Beautiful. All right, so we can put that there. And then they... Sorry, the 8 goes here. I was looking like, that doesn't make any sense. Sorry, the 8 goes there for JK. All right, beautiful. So now they want us to find the perimeter of HJKL. And again, we have the little tick mark. So this guy has to be 16. So we're just going to add all these up. So we're going to do 4 plus 8 plus 16 plus 16. And that gives us 44 is our perimeter. All right. And then they want us to find the ratio of the perimeters. So let's go ahead and do that. So the ratio is going to be 44 to 27.5. All right. And if you notice, if we do the new over the old, which would be this guy divided by this guy, so 27.5 divided by 44, we get 0.625, which if you notice is in fact the scale factor that we calculated at the beginning, which makes sense logically, because, right, the scale factor is kind of what you multiply by to get your new lengths, and the perimeter is just all those lengths added up, so it should still have the same ratio. So let's go ahead and solve for W. So we're looking for this guy here. Oops. Now, if you notice, this is, in fact, an isosceles trapezoid. So I kind of scrolled up here so we could look at the properties of an isosceles trapezoid. And one of the properties is that any lower base angle is supplementary to any upper base angle. So that means that this guy is supplementary with this guy. So we're going to take that piece of information and scroll back down to the problem we were working on. And first off, we know that this guy is supplementary to this guy. So we could do 180 minus 62, and that's going to give us that this guy is 118. Okay, so if we look, H, right, H goes with W. So that means that they have to be congruent. So if that's 118, W has to be 118 degrees.